Alright, so I'm going to try to get through some of these identities on worksheet 3. And again, I'll try to explain the process of my thinking as I go through. So let's look at number 1. I think with number 1 you could start on either side. I don't think it really matters. They both look about the same. So I'll just start on the left because we normally start on the left. I'm going to put tangent in terms of sine and cosine. So you all should be able to come up with that step. You know, when in doubt, to get some points, if you have nothing, no other idea, if you can, put everything in terms of sine and cosine. All right, so that's the trig step. Now I look at that and I say, all right, I have a complex fraction. I have a cosine in a denominator here and cosine here. So to get rid of those denominators, you have to learn how to get rid of a complex fraction, how to simplify it. To get rid of those denominators, you're just going to multiply by cosine theta over itself. You can do that because that is a form of 1. So in the numerator you have 2 terms. You have to distribute that cosine to both of those. So you have to take cosine times 1, cosine theta, and then cosine times sine over cosine. So this cosine will end up dropping out with that one. You're going to be left with plus sine. In the denominator, you distribute the cosine. You're going to get cosine theta. And again, with this fraction, the cosines will drop out minus sine of theta. So that, is again an algebra step that we need to make sure you know how to do, that you can simplify complex fractions. All right, so here you are with this. Looks pretty simple, but it's not where we're trying to go. So now you have to do a little bit of kind of peeking ahead and saying, okay, how can I go from this, which it has 2 terms in the numerator and 2 in the denominator, and that's what I want. But how can I make that cotangent and 1 and make this one cotangent and minus 1? So I look at that and say, well, cotangent is cosine over sine. 1 would be sine over sine. And again, down here you'd have to have cosine over sine and sine over sine. So what I'm going to do, because I know where I'm trying to get to, I'm going to take this fraction again, and now I'm going to multiply by another form of 1. But it's going to be 1 over the sine over itself. Again, I'm just multiplying by 1. It's a different form of 1. It's 1 over sine theta over itself. So when I do that, when I distribute, I'm going to get cosine over sine, cosine theta over sine theta, plus, when I distribute 1 over sine times sine, that's reciprocals, I get plus 1. In the denominator, when I distribute, I'm going to get cosine over sine. And again, this is an algebra step. And when I multiply there, I get minus 1. And I knew to do that because I did look ahead. I knew what I wanted to get to. And how do I go from cosine to cotangent? I have to divide by the sine. How do I get from sine to 1? I have to divide by sine. So that's when I decided what to multiply by. And then I just need to put this in terms, use my trig, and to put that in terms of cotangent. So cosine over sine is cotangent. So I got cotangent plus 1 and cotangent minus 1. Okay? So the first step was trig, but then it was algebra to multiply by a form of 1 to get this. Algebra again to multiply by 1 over sine over itself to get this. And then I went back to the trig. Okay? All right, number 2. Number 2 says I have this 9 secant squared and a 5 tangent, and I want it to be 5, but then plus 4 secant squared. So that's kind of, again, kind of the key to looking at this of what you're going to do. I'm going to break this up into 4 secant squareds plus 5 secant squareds. And I only knew to do that because I did peek over to the other side, and I knew that I wanted to have 4 secant squared. So that piece is all okay. Somehow I want this to become 5. So I look at those and say, what can I do with that one? Well, they both have a 5 in common. So let's leave this 4 secant squared alone. Let's take these 2 terms and let's factor out a 5. So I'm left with a secant squared minus a tangent squared. All right, now we got to decide what secant squared minus tangent squared. Remember, I want that to be 1. Well, let's think about it. Is it 1? You don't need to show this work, but let me make sure that you are convinced that it's 1. Remember, here's our Pythagorean identity that you need to know. That tangent squared plus 1 is secant squared. So if I take secant squared and take away tangent squared, which means I have to take it away on both sides, I will get that that equals 1. So secant squared minus tangent squared is 1. Again, you don't have to show me that work, but that's really, you know, why I can say that this piece right here is 1. So you should show me that step, that that's a 1. That's the trig part to show me that that identity is 1. And now you can just do the multiplying to say it's 4 secant squared plus 5. Okay, and that's what we're trying to get to. So the hint was to look over here and know that you wanted to have 4 secant squared. So break that apart. What's left you want to get to be 5, and then you notice there's a 5 that's common. Factor that out. Then you have to recognize that Pythagorean theorem. Okay? All right. 3. 3 looks complicated on both sides. I would say if you look at the left side, you've got some secant, so you could do some things with that. Over here, you've got this sine squared you could do something with, or this cosine squared you could do something with. So I think on this one, you really probably could start on either side. I think I'm going to start over here on this side. I'm going to work with the secant. I'm going to say secant is 1 over the cosine minus the cosine. This is the trig step, just replacing secant with 1 over the cosine. And now I look at that and see my complex fraction again. I told you we deal a lot with complex fractions. So the 2 denominators we need to get rid of are right there. So we're going to multiply by cosine over itself. So here when I distribute, cosine times its reciprocal is 1. Cosine times cosine is cosine squared. In the denominator, I'm going to get 1, and I'm going to get plus cosine squared, which is good. I wanted 1 plus cosine squared in the bottom, looking ahead, but I want to have sine squared on the top, so I look at this. 1 minus cosine squared, yeah, that is equivalent to sine squared. 1 minus cosine squared is sine squared. And again, to convince yourself of that, you know, off to the side, you can think about it. Sine squared plus cosine squared is 1. And so if sine squared plus cosine squared is 1, and I want to know what's 1 minus cosine squared, if I take that cosine squared away, I'm going to get sine squared. 1 minus cosine squared is sine squared. And that's where I was trying to get to. All right, let's see if we can maybe do another one on the back. If you look at number 4, 4's a little tricky because I see that I have 3 terms here, but I want to get to 2. And we talked something about doing conjugates, but my denominator already just has 1 term in it. So I think what I would think to do is everything's really kind of in terms of sine and cosine. So what I'd probably do is just break this up into 3 separate fractions. I would write it as cosine over sine plus sine over sine minus sine cubed over sine. Now I do know I want to get to 2 terms, so at this point I'm still at 3, so I'm thinking at some point we got to combine something later. But this would be a good start, just to write that as each of those over sine. Cosine over sine is cotangent, and that's good. That's what we wanted. We wanted a cotangent. So then I look at these and say, okay, I want that to be cosine squared. So what I'm going to do is I'm going to put these back together, and when I put them together, I'm going to factor out a sine in the numerator. So it's going to be the sine of theta times 1 minus sine squared. Still all over the sine. So all I did is I took these two, added them together, sine minus sine cubed, but then I factored out a sine. And now I see that these signs cancel out. 1 minus sine squared is cosine squared. And I'm done. That's what I needed it to be. Okay? All right, so that's 1 through 4. I think I'll do a second video to get 5 and 6 because they're a little bit longer. So that was just numbers 1 through 4.